In this video, we're going to look at the effect of polarity on physical properties. Two physical properties we'll look at are boiling point or melting point, basically the same thing, different temperatures, and solubility. And so, as you probably realize, boiling point is really a measure of when a liquid is converted to a vapor. And so this has to do with the forces that keep the liquid particles together. Solubility, on the other hand, is defined as how much of a solute is dissolved in a solvent. And this has to do with the force of attraction between the solute and solvent and how strong those forces are when they form. First of all, boiling point, and we're going to consider two samples, ethane and ethanol. And so first of all, ethane, not ethanol, ethane. So ethane is a nonpolar covalent molecule, and this is because it has both CH and CC bonds, both of which are nonpolar. So there is no polarity within the molecule. And so in terms of trying to interact with neighboring molecules, if there's no polarity, there's no delta positive, delta negative anywhere in the molecule, then there can be no interaction between them. There is no forces of attraction between molecules established between these molecules. So they will spread out maximally, basically, and this is why they're a gas at room temperature. So there are no forces of attraction, and therefore a gas at room temperature. So not surprisingly, it has a very low boiling point. It is a gas at minus 88 degrees Celsius. Ethanol, on the other hand, an alcohol, is comprised of polar carbon oxygen bonds and polar carbon hydrogen bonds, and hydrogen carbon bonds, which are nonpolar, but it has that C bond O. And so when these molecules line up with one another, because of the polarity, they can establish forces of attraction between the delta positive and delta negative components. So if you remember, oxygen delta negative, and around the hydrogens delta positive. So we get all these interactions because of the polarity, and so this polarity and the interactions mean that ethanol can establish forces of attraction between molecules. These are known as intermolecular forces, and these are what keep ethanol molecules together when they're neighboring each other or lined up together. So if we were to predict the boiling point, we'd predict it to be higher, and it is far higher than ethane, about 78 degrees, before you can break those intermolecular forces by adding energy. Second thing we'll consider is solubility. The second physical property we will consider is solubility. So if you recall, ethane is nonpolar, whereas water, in this case, is polar. Now, because of the polarity in water and the non-polarity in ethane, there is really no way to form these intermolecular forces. A nonpolar component will not form a force of attraction with a polar component. On the other hand, what we have is polarity in the water molecules, delta negative, delta positive, as we pointed out, and these parts of the molecule do form intermolecular forces. These are actually quite hard to break apart. So water will tend to stay together, and intermolecular forces cannot be established with the solvent. And so ethanol, or ethane, is not soluble in water. On the other hand, as we remember, ethanol is polar, as is water. So with all this polarity in the two different types of molecule, we will be able to establish forces of attraction between solute and solvent. And so if we do that, we can establish a network of these forces of attraction. And so this is when the ethanol dissolves in the water, and we have a solution of ethanol. So ethanol does form these interactions with water molecules. That means it dissolves in the water. And so again, ethanol is very soluble in water. It's actually said to be miscible or infinitely soluble. So just to wrap up, notice there's a bit of text, so you can pause it at the end if you like. The physical properties are dependent on the nature of the functional group. With boiling point, it has to do with a pure sample, and depending on the functional group, you can establish these strong forces of attraction, and boiling point is high. With solubility, it depends on the polarity of the solute and the solvent, and if you have the same type of solute and solvent, you get dissolving. And that concludes this video.